sklearndummyDummyClassifier. Description: the dummy classifier is a simple classifier that implements a dummy strategy, making predictions without actually learning from the data. It serves as a baseline model for comparing the performance of more complex classifiers. Inputs: X. The input features: a 2D array-like structure. Y. The target labels: a 1D array-like structure. Outputs: predictions: a 1D array-like structure containing the predicted class labels. Probabilities: optional: a 2D array-like structure containing the predicted class probabilities. Only available when the strategy is set to stratified or uniform. Steps: initialization: the model is initialized with a specified strategy for making predictions. Prediction: the model makes predictions based on the selected strategy. Metrics: accuracy percentage of correctly predicted instances. Precision ratio of correctly predicted positive instances to the total number of predicted positive instances. Recall ratio of correctly predicted positive instances to the total number of actual positive instances. F1 score: harmonic mean of precision and recall. Visualization plots. Confusion matrix: a visual representation of the model's classification performance, showing the number of true positives, true negatives, false positives, and false negatives. ROC curve: a plot showing the trade-off between true positive rate and false positive rate at different classification thresholds. Fine-tune parameters. Strategy: the strategy for making predictions, including most frequent, prior, stratified, uniform, constant. Constant: the constant value to predict for all samples. Only applicable when strategy is constant. Random state controls: the shuffling applied to the data before applying the strategy. Pass an int for reproducible output across multiple function calls. Uncertainty methods. Confidence scores: the model may provide confidence scores for its predictions, depending on the chosen strategy. Challenges and fixes. Challenge 1: overfitting: the model may overfit to the training data, leading to poor performance on unseen data. Sample use case that resulted in challenge 1: using the most frequent strategy on a highly imbalanced dataset might lead to overfitting, as the model will simply predict the most frequent class for all instances. Fixes to challenge 1: use a more complex classifier that can capture patterns in the data. Resample the training data to balance the class distribution. Challenge 2: low performance: the model may have low performance compared to more sophisticated classifiers. Sample use case that resulted in challenge 2: using the prior strategy might result in low performance if the class distribution is significantly different between the training and testing datasets. Fixes to challenge 2: choose a more appropriate strategy for the given data. Consider using a more complex classifier.